Today I'm going to be talking a bit about designing in permeable pavements as well as our DesignPave and PERMPAVE software. So just a little bit about who is the CMAA. So the CMAA is an industry association that represents the block and paver industry. We sit on standards committees to facilitate important conversations and developments. We do research with UniSA, University of Newcastle, and etc. to help further promote further research into these areas. And we also sit on policy bodies such as BIFIC and Safe Work Australia. What's our strategic vision? We like to make it easier to build in brick or blocks. Simon alluded to the fact that Australia doesn't have a standard for building in pavers or permeable pavers specifically. So we would like to address that vision. We help promote our members' products such as Adbri Masonry, as well as Austral Masonry, as well as some other of those small local manufacturers. And again, we facilitate in important conversations. We have an array of free resources available on our website, such as technical manuals, research papers, case studies. If you're ever interested in learning more about permeable paving, definitely check out our website. And here are a list of some of our CMAA members. So as you can see at the top, Adbri Masonry there, as well as at the back. Austral Masonry, Brickmakers in Western Australia, National Masonry in Queensland, and some of our smaller general members and associates. And just a bit of a content overview of what I'm going to be talking about today. So just an overview of what a permeable pavement is. For those of you who still don't know, a permeable pavement is pretty much a big drain that collects all of your water from your surface, puts it into your base course, either contains it or slowly releases it into the subgrade or through a pipe. And some examples of trafficable permeable pavements include porous asphalt, porous concrete, and finally permeable interlocking concrete pavements or PICPs. And that's the main focus of what I'm going to be talking about today. So just to piggyback off what Simon was talking about, we do have the DesignPave software as well as the PERMPAVE software. So the DesignPave software will help you with the structural design of your pavement, whereas your PERMPAVE software will help you with the hydrological design of your pavement. And these two softwares should be used in conjunction with each other to create a well-designed permeable pavement. So this is just a small list of what PERMPAVE can do. So there are three main features that are included within PERMPAVE. The first of them being runoff control, the second of them being water harvesting, and the third of them being water quality improvement. So one of the most recent updates to PERMPAVE 2.0 was the inclusion of ARR 2016. And the inclusion of this method includes more reliable estimates, improved spatial coverage of the data, and it also accounts for possible impacts of climate change. So firstly, I just want to talk a bit about runoff control and how PERMPAVE includes this. So in the PERMPAVE program, users are able to input a location-specific IFD curve. And from here, we can design our stormwater events. A hydrograph is then generated to provide you with 10 different temporal distribution patterns, where the user can choose a mean distribution pattern or any of the ones listed over there. PERMPAVE can also model a water quality improvement, so any removal of total suspended solids or nitrates and phosphates. So users are able to input pollutant concentrations, reduction coefficients, and reduction target values. And finally, PERMPAVE can model water storage. So users are able to input rainfall data, water storage requirements, as well as your daily constant water demand. And through PERMPAVE's calculations, PERMPAVE will be able to determine the required thickness for your water demands or water storage requirements. Like I mentioned before, PERMPAVE and DesignPave exist in conjunction with each other. So PERMPAVE does the hydrological design, whereas DesignPave does the structural design. And as you can see here, on the top right corner, we can see the two of them side by side. So we have the mechanistic design on the left and the hydraulical design on the right. Whichever one's highest, that's going to be your governing thickness for your pavement. So why should you choose PERMPAVE? Well, it's the only structural and hydraulical software that's available in Australia. It's based on data from the Australian Bureau of Meteorology. And like Simon alluded to, it is the culmination of over 40 years of hydrological and pavement engineering knowledge. So I highly suggest you guys check it out. So what is the main difference between residential and commercial construction when it comes to permeable pavements? Firstly, we have to determine what is the main purpose of your pavement. And here we have two factors that we have to consider. Firstly is going to be a loading requirement. So there is a major loading requirement difference between residential and commercial. And finally, we have to determine what is your pavement used for. Is it used for flood control? Is it used for water harvesting? Or is it used for water quality improvement? So this is just a very, very brief understanding of what the loading requirements are between residential and commercial pavements. So in residential pavements, you're going to get much more lighter vehicles as well as much more smaller pedestrian traffic compared to a commercial pavement. Some examples of residential pavements include driveways, domestic parking, and footpaths. Like I mentioned before, you're going to experience very, very low volume traffic, so approximately about 10 vehicles per day. In your larger commercial pavements, such as your car parks, local access roads, public footpaths, etc., you are going to experience much more higher volume of traffic, approximately about 200 to 500 vehicles a day, or sometimes even more. Compared to residential pavements, you're going to be experiencing a mixed variety of vehicular traffic. Not only cars, you're also going to be experiencing trucks, buses, etc. And now I'm just going to go through an example of a residential driveway. So for this particular project, there were two components or factors that they were trying to address. They were trying to address water pooling issues as well as excess water runoff. And as you can see on the schematic on the left, this project uses 50mm permeable pavers on top of a 25mm thick bedding layer using 2 to 5mm aggregate to facilitate water drainage. And finally, for your base course, they used 100mm of no fines concrete. And at the time, this was a bit of an overkill, mainly because it didn't have the geotechnical data, but you can get away with using single-size aggregate. And since this is a residential driveway, you're going to be experiencing pedestrian traffic as well as lighter vehicle passes. Next, we're going to be looking at a commercial bus station. I think this is the Moore Park bus interchange, the one that Eileen was discussing about. So here are some of the factors that they had to address. They had to reduce the number of stormwater pits for improved pedestrian accessibility, and they had to provide some tree protection around the existing trees that were there. And if we compare the schematic to the previous residential driveway, we find that a thicker paver was used to account for those larger vehicles and more pedestrian traffic. But over here, we can see that a much more thicker, about 1.5 times thicker base course was used. So in here, 150mm of recycled concrete base course layer was used. And as you can see on the right, we have different vehicle passes. And during those peak periods, they experienced about 20,000 pedestrians per hour. And finally, we have to consider water demand. So are you designing for flood control? Are you designing for water quality improvement? Or are you designing for water harvesting? That is entirely up to you guys to decide. And now I'm just going to be talking a bit about designing within proximity to other structures and footings. So as you can see here, we have a transition from a permeable interlocking concrete pavement to a normal concrete slab. And all you need to do is install an edge restraint or a concrete curb just to divide those two dissimilar materials apart. And this schematic was plugged from the ICPI, which is the Interlocking Concrete Pavement Institute in the United States. And similarly, asphalt and interlocking concrete pavements, same deal. You have to use a concrete curb or a type of separator. When you're designing close to a footing or a building wall, you have to ensure that none of that water actually enters into your subgrade. Otherwise, there's going to be hydrostatic pressure that's going to be affecting your footing, and that will overall lead to failure. So you have to reduce the amount of water that's going to be coming into contact with this here footing. So what do? We have two main components that we have to consider. We have to make sure that there is a minimum slope of at least 1% that is drawing the water away from the wall. And then finally, as you can see in the red line, we have an impermeable liner that redirects that water away from the wall and the footing. And far too often, commercial car parks will experience pooling at some period of their time, especially when they're using something that is impermeable, such as asphalt or a concrete slab. So, and this can cause a lot of accessibility issues. So for car parks, it's not uncommon for the parking bay areas only to be constructed from permeable pavements. As you can see here, here are some examples of where car parking bays are only used, that only use permeable interlocking concrete pavements, such as North Haven Football Club here in South Australia, as well as some small car parking along a small avenue. And from the site visit that you saw earlier today, not the entire car park wasn't paved, but instead we have a contributing area that migrates that water into the parking bays where permeable interlocking concrete pavements are used. So over here you can save quite a lot of costs. And the Concrete Masonry Association of Australia has collaborated with the City of Wanneroo in Western Australia to design a commercial car park. So the City of Wanneroo had two options that they wanted to do. They wanted to design, number one, the entire car park, so paving the entire car park in permeable paving, or they wanted to design only the parking bays only. And here is a schematic of what they actually used for their preliminary designs. So for option one, they used an 80mm paver with 25 millimeters of bedding layer, as well as a 250 thick granular base course. In option two, where the parking bays used permeable paving only, they used the same schematic as the one on the left, however they reduced that base course. And for the impermeable sections, they used concrete block pavements, the impermeable ones. And as you can see here, there is a comparison between designing the entire car park in permeable paving and designing only the parking bays in permeable paving. So the main factor that we have to see here is the water outflow. We don't want any runoff that is occurring in your car park, essentially. So both of those options met that criteria. In option one, the water quality was improved drastically, as well as water storage. However, if we compare the two together, the total cost for option one was far more expensive than option two, which used only parking bays as permeable interlocking concrete pavements. And the reason why Wanneroo wanted to choose option two was because it met the water storage requirements. So the council specified something less than 210, as well as less than 66 kilolitres. And that's why they chose option two. So really, if we look at this car park summary, choosing only the design within the parking bays only will not only save you costs, but also provide a much, much more better, more economical design. Just to finish off, we do also have an approved installer program that helps you with the design, sorry, not the design, the installation and maintenance of concrete block pavements. We're actually revamping it again this year due to last year's COVID pandemic. So this will be located in the city of Adelaide on the 12th of August. So if you guys are ever interested in learning a bit more about how to properly construct and properly maintain your concrete interlocking pavement, be sure to visit the approved installer. And this is just a little bit of a QR code of where you can install DesignPave and PERMPAVE. So with that, thanks guys for listening. I hope you enjoyed it.
So the DesignPave software accounts for water quality reductions for the majority of things. Is there an intention to include hydrocarbons as part of that? Or?
Hydrocarbons? Not at the moment. I think that might be an addition into the next version, as well as other additions that other councils have been coming forward to us with. But yeah, that is definitely something that might be included in the next version.
Chris Pratt pioneered it in the UK in the 1980s. We did some work both in Sydney and Adelaide on this. Our findings are very few hydrocarbons actually reside in permeable pavings in the long term. About 50% volatilise and go up through the permeable paving into the atmosphere, and the other 50% provide a very good carbon source for bacteria and get broken down pretty quickly. So if you look at an old permeable paving system that's been in practice for many years and try and find hydrocarbons using, there's a number of heterotrophic plate counts and things you can do for bacteria to detect them, but you can also measure them directly. And the evidence just isn't there that they reside there. So hydrocarbons is a bit of an urban myth with permeable paving. Yeah, 50% volatilise almost immediately, and about 50% stay as a carbon source that get because very little goes through. If you had a very fast draining system, say an impermeable system underlining your permeable paving, and it went straight into a pipe, then you might get hydrocarbons being flushed out of your system, but they won't reside in the actual permeable paving system.
Belinda Macklin from KBR. Just further to that, is there actually a research paper that you can call upon that will specify that for hydrocarbons and free oils?
There's a whole PhD thesis that was supervised by Chris Pratt at the Coventry University. The student walked into a laboratory every day and tipped 1 litre of oil into a permeable paving thing and then measured it over time. And it's a superb study, and it showed exactly that breakdown that I was talking about.
What we'll try to do is actually get the papers that Simon's mentioned, we'll add them to the links afterwards.
Ernie Calaro from the Campbelltown Council. James, just a question on the plinth that you need to install between either concrete or asphalt surface between your permeable pavers. What's the depth of that plinth, the suggested depth?
It's the depth between the top of your surface and the bottom of your base course, so where the subgrade lies.
Andreas Fusco, WGA. Is there any input or availability within the PERMPAVE software to take into account subgrade conditions for a soakage system? So if you're looking to use permeable pavers for soakage within your design, whether the subgrade material will be suitable?
Soakage? I'm not quite sure about soakage. Might have to direct that question to Simon.
Yeah. The only variable I think that goes into the software program is the hydraulic conductivity KS value of the subgrade, which tells you how fast it leaches down. So if you're looking for local soakage and you're actually holding onto it in the subgrade, which is not something I'd recommend, but it wouldn't do that.
Yeah, just to extend upon that, PERMPAVE also has a section where you can choose the type of soil classification. So whether it's a gravel, sealed sand, that'll address that for you.
Engineers basically don't like water in the paving grade because of the reactivity of the soils. You get movement, and so with the porous paving, I mean, how does can the software allow for compaction testing or soil testing as a built-in feature of the software to help design or even out the undulations that might occur with paving?
I don't think DesignPave or PERMPAVE accounts for that, no. Not yet at least.
All right. Well, thank you so much, James, and we'll bring you back up for the panel at the end, but if anyone's got any more questions. Thanks very much.